I am on page number 8 of the homework that you guys picked up yesterday. I'm going to model 3 problems, 1, 9, and 10. And 1, 9, and 10 will provide you the skills to do all the other ones that you need to do. So,
Page what?
Page 8. Here you go. So again, the reason we're doing this is where we're going is on Monday. I'm going to teach Monday and today. We're going to talk about trigonometric equations, which are basically equations like this, except with cosine and sine in them. But before we do that, we want to review some basic algebra stuff, so we're in good shape to solve those problems. So let's dive right in to problem number 1. Alright. So number 1 says 2x minus 3 2x minus 3 squared minus 7 times 2x minus 3 plus 6 equals 0. Some people yesterday in class already had started working on this, and they were multiplying this out. So they just took this, they said, let me square it, they multiplied all this, they combined like terms, and then they got the answer. There's a bit easier way of doing this, and that way is called U substitution. And we had talked about this last semester, and U substitution just says, if I look at this equation, this is repeated right here. So what we have here in the pink is repeated twice. So if I were to make this U, in other words, if I were to say let 2x minus 3 equal U, then I could rewrite this equation as the following. Instead of writing 2x minus 3, I could just put U. So U squared minus 7U plus 6 equals 0. Any questions on how we did that? By the way, I should point out, I was helping Kimberly's older sister who goes to U of H in her Calculus 2 class, and we use this strategy, so it's something that we'll repeat later on. So now this is very factorable from your algebra days. Some of you will use the box. Others of you might be able to do it without the box. Regardless, we should be able to factor this and make sure you get this. So please verify that this is what you get. Please verify that you can get these as the 2 factors. You can get these as the 2 factors. So, are there any questions on how to get these as the 2 factors? So once you get the factors, you can use what Kurth loves to say over and over again, the zero product property, where you can split this up and set each piece equal to 0 and solve for the roots. So we split this up and we say U minus 1 equals 0 and U minus 6 equals 0. By the way, this only works when we're equaling something to 0. Hence it's called the zero product property. So now we've got this. So let's replace, but here's the interesting piece. We need to replace this U, or rather these U's, with X's. Because we want X's, we don't want U's in the final answer. We're solving for X. So, instead of U minus 1, I'm going to replace U with this. I'm going to do that on the next page, so I'm running out of space here. 2x minus 3 goes in for U. The minus 1 is still there. Over here, 2x minus 3, the minus 6 is still there. Questions on how to do that? And now we just solve for x. And here we have the roots. So for all of these problems on page 8, you are solving for the roots. Let me stop here before I go to number 9 and see if there are any questions. Mariah. That's fine. Hey, Mary.
Is it possible to get like 2 answers, or can we get like 1 answer on some problems?
Some of them you might just get 1, some you might get 2, some you might get 3. I don't know. I actually do know for each one, but okay. So that's number 1. So the strategy here, use substitution, might be useful later on. I mean, it might not be, but it's helpful to have in the toolkit. Okay, let's go to number 9. All right. So number 9 says 1 minus t over t plus 2 over t plus 1 over t squared minus 1. So we look at this problem. It would have been great if we would have had one fraction divided by another fraction. Because if we had had one fraction divided by another fraction, then we could have done keep, change, flip. Unfortunately, we have two fractions here. So perhaps there's a way to take this yellow circle and focus just on this numerator and write these two fractions as 1. If we can do that, then we're in great shape. So let's figure out how to do that. So let me take the yellow box. I'm not going to focus on the denominator right now, just the numerator. The goal is let's make the numerator into one fraction. Bless you. So here we are. This is supposed to be 1 over 1, not t. Let me rewrite this. So we have 1 over 1 minus t over t plus 2. And the question is, how can we make this one fraction? So I have one fraction minus another fraction. As you all learned probably back in 6th grade, you need a common denominator. So basically, we need to multiply this fraction by t plus 2 over t plus 2. We need to multiply the top and bottom by the exact same thing, also known as fancy 1. And the way we got t plus 2 is we could see that if we multiply this by t plus 2, denominators will be the same, and we're in business. So let's go ahead and see what happens. T plus 2 times 1 is t plus 2, divided by t plus 2 times 1 is t plus 2, minus t over t plus 2. So now we see that we have two fractions with the exact same denominator. So just go ahead and subtract them straight across. So what do you get? Well, on the top you have t plus 2 minus t, and of course the denominator stays the same. We simplify the top, and the t's go away, so we have 2 over t plus 2. This is just a way of rewriting this as one fraction. Questions before we go on? Let's wait. So the reason we cannot do that is because we've got some addition here. If this were multiplication, we'd be good. Because we're adding it, not allowed. So now, let's replace this numerator with this one fraction. So then we'll have this fraction divided by this fraction. That's where we're going on the next page. So we will have this yellow divided by the old denominator. We have not done anything with this. Keep it the same. So here we are. Now we have keep, change, flip. Fraction divided by fraction. So I'm going to keep the numerator. Change the division to multiplication. And flip this fraction. Many people want to just multiply this straight away. This is just, two fractions, multiply the top, multiply the bottom, you're good. Before doing that, though, it is helpful to factor, because you never know what might cancel out. So I would factor this right here. Remember, this is the same as this. This is what we call a difference of squares. A squared minus b squared is the same as a minus b times a plus b. Again, we talked about that unit 3 last semester. So now let's rewrite on the next line. We have 2. We didn't do anything to this fraction. Multiplication is still there. This numerator is now t minus 2 times t plus 2. The denominator is still t plus 1. And now we're in business. Because this cancels with this term, t plus 2, cancels with this t plus 2. What are we left with? Well, we've got the 2 times t minus 2, all divided by t plus 1. Questions? Okay, so let's continue on. Now, distribute here. 2 times t is 2t. 2 times negative 2 is negative 4, all divided by t plus 1. And the question is, where does that equal 0? We want to find the roots. Where does that equal 0? Well, if you want a fraction to equal 0, then what has to be true? The numerator must be 0. Don't care about the denominator. Remember, you don't want the denominator to be 0. If the denominator is 0, the fraction is undefined. We want the numerator to equal 0. So we want 2t minus 4 to equal 0, so we want t to equal